Imagine two workers pushing a heavy concrete trolley. One pushes from the handle, the other from the middle. Surprisingly, the trolley moves exactly the same way. Does the location of force really matter? This question leads to one of the most powerful concepts in engineering mechanics, the principle of transmissibility. What is it? Simply put, if a force moves anywhere along its line of action, the external effect remains the same. The exact point doesn't matter as long as the force stays on the same straight line. The technical definition states, a force acting on a rigid body can be applied at any point along its line without changing the effect. Engineers use this to simplify complex systems, shifting forces to make structural analysis much easier to calculate. Every force has three elements: magnitude, direction, and the line of action. The line is the key to transmissibility. Crucially, this works only for rigid bodies, like steel or concrete, that do not change shape under pressure. Note that while external effects stay the same, the internal stress distribution inside the material can actually change. In case 1, we apply force at point A. In case 2, at point B, both yield the exact same motion and equilibrium. For equilibrium, our equations for sum of forces and moments remain valid even when the force location shifts. In the field, we measure this in newtons or kilonewtons. Remember, 1 kN equals 1,000 newtons of force. Here's a shortcut trick for your exams. Just remember, same line, same effect. It's that simple. Let's see this on a real site. When a crane lifts a beam, the cable might attach at different hooks. Engineers analyze the load along the same vertical line, regardless of which hook is used, thanks to this principle. From site engineers to consultants, every professional drawing a free body diagram relies on this rule. If ignored, you get wrong bending moment calculations. This leads to cracking, overloading, or even structural failure. In the worst case, a crane lift could fail. This concept directly impacts site safety and design accuracy. While we don't test the principle directly, we use it in structural load tests to verify our design calculations. Measured values must match design codes like IS 4526. These standards rely on correct force analysis. A senior engineer once told a junior, "The structure only cares about the line of action, not the exact point." Understanding how forces truly behave is what separates average engineers from the great ones.